Okay, so we're factoring. Now, like I said, with factoring, we talked about two methods. We kind of talked about, oop, we talked about like brute force, and then we talked about the AC method. We talked about the AC method. What I'll do is I'll come back to that, right? But AC method and brute force method. So now let's talk about this. We got rational functions. Rational means ratio, ratio means fraction. So I got a denominator and a numerator. So I got two functions. It says state the domain of the function. If I'm trying to state the domain when I've got rational functions, all I do is set the denominator to 0, then solve. So if I'm trying to figure out the domain for this first function right here, right? I'm going to take x squared minus 9 equals 0, and then I'm going to solve it. Well, can anybody tell me what x squared minus 9 is? It's something that we talked about a few times. Yeah, but there's a term that we use for it. Does anybody remember what it is? You need that, bro? You need that? The review. Do you need it? You need the review. Okay. Okay. So anyway, that's the difference of squares. That just means that I got x plus 3 times x minus 3 equals 0. And then what is that? X equals 3 and negative 3. So what does that mean? Well, what that means is that my domain is all real numbers except 3 and negative 3. Now, what is that about? Well, remember, this is a ratio or a fraction, and you can't have a 0 in your denominator. So 3 and negative 3 give me a 0 in the denominator. So I can plug in whatever numbers I want except 3 and negative 3. Yes, that's the domain. This is the domain right there. That's the domain. This is the work to get the domain. That's the domain. But I've always said you always show your work because maybe you messed up and put fours for some silly reason, or maybe you put sixes. If you showed me that with the wrong number and you just accidentally put the wrong number because you weren't thinking or whatever, well, 9 is 4.5. So I'm going to put 4.5 here and minus 4.5. I might still give you some credit because you showed me the process. You just got your numbers wrong. To me, process over real that correct answer. The correct answer to me is one piece of the whole thing. So if you show me a good process with the wrong answer, more than likely I'll give you most of the points. If this was worth 3 points, just this first part, you'd get 2 out of 3 if you gave me this process with the wrong numbers. Okay. So then we talked about end behavior, determining end behavior. So we look at our function. And when we look at our function, we remove the constants and simplify. So if I remove the constants, I'm going to have 2x over x squared. And then I simplify that. What's the last thing I can do to that? I can take an x out. So I'm going to have 2 over x. Now, there were 3 instances that we talked about. We talked about if you had just a variable. We talked about if you had a variable in your denominator. And then we talked about if you had a constant, some number that didn't change. So your end behavior, what does your graph move towards? Well, if it was x, then it was just infinity or negative infinity. Because whatever number you put in, that's what it's going to go towards. If you had 1 over x, it was going to go to 0. Because remember, when you got a fraction and your number on the bottom just keeps getting bigger and bigger, it's getting smaller and smaller and smaller. So it's going to go to 0. And then a constant, like if I got 5, then your end behavior will be going towards 5. So in this case, if I remove the constants and then simplify, I got 2 over x. So what's my end behavior? So as x approaches positive infinity, f of x approaches 0, and as x approaches negative infinity, f of x approaches 0. Because it doesn't matter whether it's positive or negative. As you got a fraction, as you got a denominator that keeps getting bigger and bigger while your numerator doesn't move, it's getting smaller and smaller. And it doesn't matter that it's a 2 instead of a 1, because that 2 is inconsequential. So as your numbers get bigger, your stuff is getting closer to 0. If it was x, I would say as x goes to infinity, f of x goes to infinity. As f of x goes to negative infinity, or excuse me, as x goes to negative infinity, f of x goes to negative infinity. So we also had a possibility once where it was x squared. When we simplified it, it was x squared. And so then it was as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, it still goes to infinity, because the bottom line is if something's taken to the second power, you're not going to get a negative number out of it, right? As no doesn't matter what number you plug in, if it's x to the second power, it's always going to be positive. So I would just say as whatever, whether it goes to positive infinity or negative infinity, the answer is going to go towards infinity. So we had it to where it was one time like that, but these were the three general things that we talked about. Was if I had an x, if I had a 1 over or something, some constant over x, and then if I had a constant, like a straight out number like 4. As x goes to infinity, f of x goes to 4. As f of x goes to negative, or as x goes to negative infinity, f of x goes to 4. You know. So those are my three possibilities. Like I said, we sort of have four-ish, but not really. So that's the process though. You take your function, your rational function, remove the constants, and then simplify. Now, if you have a problem that has something that looks like this, and I say remove the constants, well, you're gonna get rid of the -5 and a +5. You're also gonna get rid of the x, because I don't want to sound confusing, but when I say remove the constants, you were looking at the highest power of x, because there was only a constant and a power of x. But if you're looking at some situation that's like this, consider the function means that's my problem. It's like think about this thing in relationship to these three things. You're all right, don't sweat it. So anyway, like I'm saying, if I had a problem that looked like this, okay, when it came to determining in behavior, you would scratch all of this off and just think about the highest powers of x, okay? Because if x squared is up there, the x kind of becomes inconsequential after a while, because exponents increase quickly. No, I'm saying that if you had a, yeah, you don't, because they're being added or subtracted, you don't just cancel stuff off like they're being multiplied. It's a difference. So you would just look at these two things. You would just focus on these two things. You focus on the highest power of x. All right. Yes, you could take an x out of the top and bottom. Yep. As x approaches infinity, f of x approaches infinity, and then if as x approaches negative infinity, f of x approaches negative infinity. If we were talking about this one right here. Yep. Okay, state the vertical and horizontal asymptotes. So the vertical, okay, those come from your denominator. That comes from your denominator. You set it equal to 0. Oops, can't spell. So for this same problem, my vertical asymptotes is x equals 3 and x equals -3. Yep. Or you can think about it saying your excluded values. Let's not do all that. So what about your horizontal asymptotes? So you think about your end behavior. Think about yeah, well hold on. So the output for your end behavior. So if I have something specific, then that means that I will have a horizontal asymptote. So like if I looked at my end behavior was as x approaches infinity, f of x approaches 4. So then my horizontal asymptotes would be y equals 4. If this problem right here, this problem has an behavior that as x approaches infinity, f of x approaches 0. As x approaches negative infinity, f of x approaches 0. So 0, y equals 0 would be my horizontal asymptote. But if I have something that's like x, then it doesn't have a horizontal asymptote because it doesn't have a specific thing that it's approaching. It just approaches whatever number I'm putting in there. Or it just goes on forever either way. So let me take a pause and say, do you guys understand what I'm talking about, or am I talking in a circle? Do you guys understand what I'm talking about, or am I talking in a circle? Like I said, if there is a specific value that my function approaches as far as end behavior, then I have a horizontal asymptote. But if it doesn't approach something specific, if it's general, as x approaches infinity, f of x approaches infinity, then I don't have one. If as x approaches infinity, f of x, then 3 would be my horizontal asymptote. If I have a specific value that it approaches, then there's none. You say none or no. Horizontal asymptote or no horizontal asymptote. But you're y equals 3. Y equals 3. Yes, I'm saying that that's what you get for your B, for your end behavior. Okay? So so then you just say y equals 3 for your horizontal asymptote. Or in this case, like I said, for the problem that we've been doing this problem right here. We're doing this problem right here. So if we're just being consistent and looking at that problem, right? we're doing that problem, then the answer would be y equals 0. That would be my horizontal asymptote. Mhm. I don't know. I said if it's a general thing like x. So x would give you as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. See, that's something general. You don't have a specific value, so then you wouldn't have an asymptote. I guess that's one way to say it. Okay, for this problem, vertical asymptotes, x equals 3, x equals negative 3, so you have 2. For this problem, horizontal asymptotes, y equals 0. Yes, yes. Ask the question. Vertical come from your excluded values, the values that you can't put. Because think about what that means. I'm telling you that you got this function and I want to graph it. I'm telling you that you cannot input these numbers. That means if I graph it, when you look at the graph, those numbers aren't going to be on your graph because you can't put them in there. So there's going to be invisible lines that go through that say I can't touch those. And that's what those asymptote lines represent on your graph. It represents values that I can't use. And in behavior, this says that as my numbers get bigger, or as they get bigger, more negative, I guess you could say, they're going to approach 0. It's never going to hit 0. It's just going to approach it. So then I have an invisible line that's on that 0 line that says I'm not going to touch that line. That's what an asymptote is. It's an invisible line that you use to guide you to say for my graph. All right, let's see if we can do something else. Okay, simplify. Simplify is just a matter of being able to factor stuff. So if I look at A, what the first top part on A? All right, what is that? What would I call that? We said it earlier. Starts with a D. Starts with a D. The difference of squares, because x squared is a perfect square and 64 is a perfect square. So it's x plus 8 times x minus 8. It's the way that I factor that without having to do any work. I just see that, oh, that's a perfect square, that's a perfect square, and they're being subtracted. I know what I got. So now, for doing something like the denominator, I do the brute force thing. I would say, okay, I got two parentheses. I got x and x. This is minus, so it tells me my signs are different. So I know I got a plus and a minus. And now I need two numbers that when I multiply them, I get 32, but when I subtract them, I get 4. 8 and 4. The sign in the middle is the same sign that the 8 has. So that's x plus 8 and x minus 8. Now that I got that, oh, I'm sorry. Yeah, I'm sorry, I messed up. Yep. Okay, so x plus 8 and x minus 4. So now that I got that, what are my excluded values? X cannot equal. What are the things that x can equal? Positive 4 and negative 8, because they give you 0 in the denominator. And then I can just finally factor, or reduce, excuse me. How do I know what? Brute force, because this is plus in the middle and this is minus. So I know my signs are different. The biggest number, I get the biggest number gets that sign, right? The biggest number gets that sign. So anyway, so finally I can reduce because I've got x plus 8 on the top and x plus 8 on the bottom. So my final answer would be x cannot equal negative 8 and positive 4, but it's x minus 8 over what? Yeah, x minus 8 over x minus 4. Because it's a fraction. The stuff the same on the top and bottom you cross off. If I gave you two, hold on, hold on. If I gave you this right here, 2 times 5 over 2 times 8, I cross off the 2's because it's reducing. That's 10 over 16, right? If I divide by 2 on both top and bottom, I get 5 over 8. That's all I did here. I got the same thing on top and bottom, so I can cross them off or I can divide them out. So like this one, like B and D, if I look at this, what does the top have in common? The two terms on the top. I got a 4, so I pull a 4 out and I got x squared minus 100. And what is x squared minus 100? Yeah, but what is it? I've only said it like 300 times now. It's the difference of squares. So I'd have 4 times x plus 10 times x minus 10. That's on top. And then what is the bottom factor to? Just brute force. I got x squared, so that's x and x. I've got plus 100. So that tells me I got the same signs. I'll look in the middle. I got the same signs, but it's negative. So that means I got two negative signs. And not 10 and 2, because I got 100. I got two numbers that multiply to give me 100. 10 and 10. So then what are my excluded values? Mm-mm. What are my excluded values? Just positive 10. X cannot equal 10. Because if x equals 10, I get 0. Because they're both negative. Yeah, but see, the top doesn't matter. Remember, you can't divide by 0. That's the denominator. If the numerator's got 0 up there, so what? That's fine. So x cannot equal 10. So that's my excluded value. And then I can cross one of those off. And so my final answer will be 4 times x plus 10 over x minus 10. As long as you remember, you got to have your excluded values. Yeah? Wait, what? Yep. Okay, why did over here or over here? Yep. Okay. The excluded values came from the bottom. So there's x plus 8. If x is a negative 8 plus 8 is 0. I get 0 on the bottom. If x is a positive 4, I get 0 on the bottom. Because remember, I've got these two groups that are being multiplied. And the zero product property says, doesn't matter what you multiply, if you multiply 0 by it, you get 0. So I only need one of these things to be 0. That's why I have two excluded values. I can't have negative 8 or positive 4. Because if it's either, I get 0 in the denominator. Not the top, the bottom. Now, see, on the bottom over here, I only have negative 10. So then that's why my excluded value is only positive 10. Because if I put in a negative 10 on the bottom, I get negative 10 minus 10. That's negative 20. That's okay. And negative 20 times negative 20 is positive 400. That's okay. I can do that. Okay. So now I've got the composition of functions. Composition of functions is I just got one function, I'm placing it into another. So right here, if I got f of g of x, that means g is going inside f. So g is x squared, f is 2x minus 7. So that would be 2 times x squared minus 7. Now see, composition of functions doesn't say that that I'm trying to solve something. I'm not trying to solve anything. I'm just trying to simplify because I'm not going to get a solution from this. All I'm going to get is 2 times x squared minus 7. That's going to be my answer. It's okay. 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 You didn't have to tell me that now, but okay. You could have just told me that tomorrow. But that's okay. But look at C. C, I have a specific value because they want G for negative 2. So G is x squared. So that's going to be negative 2 to the second power. And negative 2 to the second power is positive 4. Y'all make stuff way harder than it needs to be. I'm just plugging in stuff. All you're doing is plugging and chugging, whether you're plugging in something general or you're plugging in something specific. So let me go back to the first one. Okay, this is f of g of x. F of g of negative 2. So what's g of negative 2? There's g. If I plug in negative 2 for x, that's negative 2 squared. What's negative 2 squared? That's 4. So then that means I got f of 4. So then I plug in 4 here, right there. I started off f of g of x. General. Okay, let's do C. Okay, I'm holding on. What am I holding on for? Let's not do that. F of g of negative 2. So if I plug in negative 2 for g, I get negative 2 squared. So then negative 2 to the second power is positive 4. So now I got f of 4. So now I just plug 4 into f. What? No, I wasn't done. She asked me a question, so I stopped to listen to her. Sorry. F of 4, or excuse me, f of 4 equals 2 times 4 minus 7. Yes, that's 8 minus 7 is 1.